So welcome to perhaps the world's first Bluetooth low energy battery management system. The way I have set it up is the following. For every 4 lithium cells, I install one battery management system shown here. This is connected to the negative pole of the lowest battery cell, and here there are 4 wires going to the positive pole of each cell. The battery management system itself checks the voltage of the cells, and once the voltage rises to a certain level, it shunts off a certain amount of energy to balance the cells. At the same time, the voltage is transmitted to another device shown here. This device records all the cell voltages and displays them on a small OLED. So this module here is not yet finished. I still have to make a PCB out of it, but basically the function is that the different voltages are picked up from the local battery management system. It is displayed here on the OLED. I can connect about 30 of these BMS modules to one central device, so that means about 120 cells. Here the central device records all the cell voltages and can take certain actions. For example, during discharging, it can stop the power to the motors, or it can stop the charging during the charging process. During the initial installation, the BMS modules need to be paired with the central device, which is done basically with this pair button shown here. Once they are paired, they display the voltages and take certain actions as discussed. In case there is a failure, communication failure, the central device automatically displays this on a display. It shows which cell has an issue, or in other words, which module, actually, which BMS module has an issue, and can again take actions, for example, switch off the charging to make sure there is no overcharging. To simulate this, let me quickly remove this power. So now the power is switched off here, so there should be a short delay here. So now you've seen it has changed to this inverted display view, meaning that the communication of this BMS module has stopped. I'm going to plug it back in here. So with a certain delay, the unit will start again, will start communication, and soon the display will be back normal. So now it's just again on normal display. In order to save energy, these BMS modules send or communicate with the central device every about 10 to 15 seconds, and in between they go into sleep mode. I've now disconnected the negative pole of the BMS and put an ammeter in between to measure consumption. You can see now it actually displays 1.16 milliamps during the sleep mode, and once it goes into the transmission of the voltages, it goes up to 4.5, but actually there is a peak I have measured of more like 15 milliamps, but still in the average the consumption is probably less than 1.5 milliamps. So that is for 4 cells. In other words, the actual consumption per cell is more in the region of 0.4 perhaps milliamps. Before I used these devices here. They are small BMS modules which are installed on every single cell. This was the original device. The next the version was that one. They're called mini BMS. They worked very well. I had never a problem. Unfortunately, they are not supplied anymore. These devices are basically connected on every cell, and they do the same shunting of the cell in case of overcharging for balancing. At the same time, they need a cable here, shown here, which is connected from one module to the next, and finally to another central device shown here, which then takes the actions, switching off the power supply. Here you can see this installation of these mini BMS modules. Here they're installed on each cell and then cabled to the central device. Here you can see the battery pack of my Detroit Electric, an old-timer 1922 electric driven. This package I have changed a few years ago from standard lead acid batteries to lithium iron phosphate batteries. There are a total of 28 connected in series and 2 in parallel, meaning a total of 56 cells. Each cell has one mini BMS for balancing and control of voltage. Additionally, I have this central BMS here, which is a separate pack. I will eventually replace this with my own development, which makes it significantly simpler. This is the battery pack in front of the car. Another additional 28 cells here inside. They are both connected in series, giving these 110 volts. In the back there I have another electric car. It's a 1905 triple horn. This is still equipped with standard lead acid batteries. I will eventually change these batteries also into lithium iron phosphate batteries, which will eventually need another BMS. So that's it. I guess this will keep you busy in the future. If you have further questions or are interested in getting some supplies, perhaps I can make some additional units, just let me know. Bye.